So I'm just going to give some highlights and talk about some natural hazards and where soil moisture fits in that realm. Um, we'll just jump into it, keep on time here. So one thing that I read a lot, and I've written this sentence about 1,000 times, soil moisture is a critical environmental variable for agriculture and weather forecasting. That's me telling you it's important. And one of the things that we learned yesterday from our communications workshop was we need to be better communicators about this. So how about we be a little more specific and let people know exactly why soil moisture is important. Making sure everybody, if I can move this. So soil moisture is essential to everyday life. It helps farmers grow our food, guides accurate weather forecasts, and supports healthy ecosystems, if you care about that sort of thing. Understanding how much water is in the ground allows us to predict droughts and floods, protect crops, and manage water resources wisely. That sounds a little AI, because it completely is, but it is something that it better describes why soil moisture is important. We're all scientists. We're already convinced that soil moisture is important, but we need to rethink that everything we do is not only being read in papers, it's probably not even being read in papers as much as it's being heard by people that you're talking to on an everyday life. So I just want to relay that from our experiences yesterday at the communications workshop and past experience, that we want to really sell our science as much as possible. If I can click. As well, in an effort to do that, we've generated this graphic a few years ago that kind of shows where soil moisture plays in the different realms of carbon cycle, water cycle, and energy cycle. It's incredibly important for a variety of things: agriculture, drought estimation, dust generation, runoff. We heard last week from someone in Montana said, oh, they've already had their first dust bowl of the year. So, what does dust have to do with soil moisture? Well, without soil moisture, you then get dust and wind erosion. So little things like that, moisture connects everything, or lack thereof. So most people are like, oh, but I have soil moisture, I don't worry about it. But we're here to remind people that, well, just because you have it right now doesn't mean you're going to have it in the future. And we want to understand how much we have and which direction it may be going, because we're all using more and more. And last night in the discussion of how many data centers are we seeing pop up everywhere, and are data centers thirsty? I know they keep telling me don't pour water on my computer, but they seem to want a lot of water for their data centers. So I'm still trying to work that out. I'll pour some water on Ronnie's later to see how it goes. Not mine, of course. But this is the National Coordinated Soil Moisture Monitoring Network, and I hate to go on record with this, but I did not pick the name. Elise did not pick the name. That was a congressionally mandated name that we use, and we pivot that name a little bit to say that this is a network of people. We have a great network of people here, all studying soil moisture science. And we tend to focus more on the in situ side, but the in situ does not live in a silo. It's not out on an island on its own. It interacts with modeling, it interacts with remote sensing, and all of these things need to come together because we need those three different legs of the stool for soil moisture science. So we do focus on the in situ side a little bit more than most, but you'll see that we connect, and we have speakers from all these different realms as well. There's a QR code on there if you want to see the origin of this paper, this figure. Another thing that's come out recently, and you'll see a list soon if I remember my slides right. But I thought about this yesterday. Like, we're all talking about, I need data, I need data. Well, here's your data. Go ahead, have fun. You don't understand this? It's just a bunch of numbers to you until you actually have it in context. You know where it is, you know the time that it was collected. What format is it in? Is this fractional available water? Is this water content? Is this percentage of saturation? All those things are metadata, ancillary data that describe the data. And that's just as crucial. So Brianna Wyatt generated a metadata guidance document. We have a quality assurance and quality control document also out there. But this is an illustration of, I hear it, I just need more data, more data. Well, here you go. Go crazy, right? So within this process, and this slide I used way too many times, but we start with our application. Who's paying for this, first of all? What is the need for our network or our satellite? We all have a reason for doing something, and someone's paying that bill. So the application tends to lead the design. And then the siting and the contracting that makes everything happen. We have many contractors in here as well. Then we have a quality assurance document that talks about how do you design so that you have good quality data coming out of it. Assurance comes at the beginning. QR code for that document. Then we have the installation. We have a video guide there for that with a little dinosaur in it. Then we set up our communications. We get that wonderful data flowing in a nice format. And then we have our metadata coming out of there, which is well described in our guidance. And then we finally have quality control at the end, making sure that the data we're getting is right. That's probably a question I get second most often is, besides where's the bathroom, is my data right? It doesn't look right. Does this look right? I don't know. I can't tell. And we have procedures that we can use to try and make that data give us more confidence and trust in the data that we are collecting. And here are those documents online. I'm going to just skip that. Another more recent event was the publication of Understanding the Potential Use of Soil Moisture Information in the United States. So NIDIS, I think, at least sponsored a study to help document and give us the numbers we need. So we all say soil moisture is important. It's used for weather forecasting, it's used for drought forecasting, things like that. But do we have dollar signs? Because a lot of people only respond to dollar signs. So we needed to start documenting economically what is the impact of soil moisture data. And this work out of Oklahoma State made one of the first attempts to do that. There are a couple others out there as well. So this just came out in March, and we're happy to see that. This came out of the last meeting or 2 meetings ago, I think, where we identified the need to document these resources so that you all, as you go forward trying to justify your jobs, have this resource to say, here is a peer-reviewed journal article that documents quantitatively the value of the work we're doing. And we continue to hopefully have more of that coming out. As well, resources for network operators have been published online. The QR code there is for the website. This is all on drought.gov. This was put together by Elise and her team to talk about what does budgeting look like and calibration installation. And it's not all our information. It's not all NIDIS sites. There's a collection of other information posted here as well, but it's kind of a one-stop shop for information that network operators and people using data might be able to go to and kind of get a harmonized answer to our questions, because we tend to get divided up into like searching online or asking AI, and then it hallucinated something. So here's an authoritative index of information that has been curated and will be updated for folks. Now I'm going to natural hazards. So again, this poster is online for folks that want to post it in your universities, high schools, elementary schools. We want everybody to understand why soil moisture is important. And this is that larger graphic with information and some words to describe the value and how soil moisture plays a role. But within this role, we all understand the natural hazards part. That's kind of the big dollar value, right? And here they are. They got a little moved around. Sorry, drought here, dust generation, landslides, flooding, wildfires. That's a lot. That's a bad Monday, right? I don't want that Monday. But all of these, it's actually, when I started searching online for this, it's called a complex event, I think. And these things happen together. So drought can lead to wildfire. Landslides can lead to flooding, because landslides into a reservoir then over top of a dam and make the dam break. So these things don't exist in isolation. They can build upon each other, and they can exasperate each other. So you have drought, you can get dust generation that then makes air quality harder. And then we have flooding that you have wildfires also that make air quality, and everybody likes to breathe. Last time I checked, breathing is kind of essential. So soil moisture and breathing, what does that have to do with anything? Well, dust generation, wildfires, and smoke. I know that I have been told last year I can't go out into the environment. I can't go out and work today because there's too much smoke in the air from Canadian wildfires. So people blame wildfires. I blame the Canadians personally. I think it's their fault, but also it's the wildfires, I guess, a little bit. So putting this all into one context, and again, this is a visual that is completely generated by AI. But it kind of helps put everything, so there's probably some typos in here, but it does help to show the extremes of, we have drought, so it's lack of soil moisture, we have too much on the flooding side. And where do we want to be? We want to be Goldilocks. We want to be in the middle. That's where we want to operate most of the time to avoid the big problems. And it's this kind of communication that we're hoping to drive natural disasters or extreme events in some cases. Extremes, they're at the edges. Edges of what? The soil moisture spectrum. Is that why they're called extreme events? Maybe. Is soil moisture responsible for everything? Yes. I think that's my last slide. So I just want to put that context, get everybody started thinking about this. We're going to talk about lots of things besides natural hazards. But soil moisture plays a critical role, and it's usually the highest dollar value. You can see as you drive around Asheville and take a nice tour, and then remember, how high was this water that came through? And how many people's lives are disrupted by this because of water. And we have to live in this world, and we want to have better plans and make better decisions. And soil moisture is a key part of that. It's that connection between all these different pieces. So with that, make sure I'm on the last slide. I am. And now we're 1 second late, 1 minute late.